So, how are the lengths of the sides of a right triangle related? This is the question you will need to be able to answer in your note summary when we get done today. Cohen, can you please read to us about Pythagoras? Thank you.
Pythagoras was a Greek mathematician and philosopher. He was later used in most later fields in mathematics. In mathematics, the rule is called a theorem. So the rule that Pythagoras discovered is called the Pythagorean theorem.
Nailed it. Okay, so does anybody remember what the Pythagorean theorem is? Okay, my suggestion is to write this down. Pythagorean theorem is a squared plus b squared equals c squared. Like, could you just replace the letters? It wouldn't change anything about the way that you do the problem. The important part is knowing C, and we'll talk about why. Okay. So if you wanted to change your letters, you would just need to make sure that you were still doing the C part correctly and putting it in the right spot. So, and that's not going to move with my paper. That's unfortunate. It should move with my. Oh no, it's going to move that. There we go. Okay. So on a grid paper, draw any right triangle. Label the lengths of the two shorter sides, A and B. Okay, so if I have here's what's that? Oh yeah, that's all right. So if I am wanting to draw a right triangle, okay, the most important part is that I have two sides that are perpendicular to each other. Okay, perpendicular means that I've created a right angle at their intersection. Okay, we would label those sides, we'll say A and B. Okay, so you should have your triangle that you drew labeled. If yours doesn't look like mine, that's fine. If it does not have a right angle, then that's not fine, and you need to fix that, okay? Because it does need to have a right angle. So these are the kind of two legs of a right triangle, okay? The adjacent sides. Adjacent means next to each other, facing in different directions, okay? Otherwise, we just say side by side, right? If I'm standing this way, okay, Suzette is adjacent to me because she's not facing the same direction as me, but she's right next to me, okay? So what is the longer connecting side called? Do we remember? We will label it C, okay, but it actually has a specific name, and it starts with an H. That name is called the hypotenuse. Hypotenuse, and that is C. The hypotenuse is always directly opposite of the right angle. Okay, so wherever your right angle is, C is the side that is opposite away from that. Okay. Okay. We're actually going to skip part of your little packet that you have here because we don't need to do all of this business. So let's go down. I keep moving the stinking paper. Okay, so if we will skip to the second page, okay, where you have all these right triangles. If you have your own ruler, you may get it out. If you don't, we're just going to take one and pass them. There we go. If it's in the plastic, you can take it out. Okay, so this next section, okay, you're going to use a ruler to measure the longest side of each triangle. Nice. Okay, so you are only using the ruler, okay, to verify the lengths of all of the hypotenuses. Okay, so for letter A right here, if we labeled this A and this B, you need to measure C. Okay, and then mark it down. Make sure that you recognize the unit of measurement. Okay, if that triangle says centimeters, use the centimeter side of your ruler. Should the hypotenuse be longer? Yes. So verify, okay? Please repeat this step for all 4 of them. Yeah, it's yours. Yep, it's yours. Hmm? Mm-hmm. Mm-hmm. Really excited to meet some of y'all's parents tonight.
Yeah, my mom isn't coming.
Mr. Man,
Hi.
can I see Ada Phillips, please?
Yes.
Hi, Ada.
Hey guys. Here I'm about to. Well, you know what? I'm recording. Remind me to tell you something after I get done recording. Okay. I just don't want to click you. So. Okay. I know now you're all interested. So, what do we get for A? D. 5 centimeters. Okay. Anybody get anything different? Okay. So these, these rulers, especially the wooden ones, could potentially get chipped away. Okay. So if your measurement's a little off, that's fine. But yes, so 5 centimeters. Okay. So, what about letter B?
5.2 centimeters.
5.2. Okay. So this is something, and this actually just popped into my head. This is one of those things where like you learn something a long time ago and you forget it for the most part. But when you forget stuff, it's just because it's not at the forefront of your brain, but it's hidden somewhere back there. Okay, and every once in a while, your brain just like throws it to the front. So I believe, and I just want to verify if this is true for all 4 of these triangles right here. The hypotenuse should be longer than either of the 2 shorter sides, okay, but not longer than if you added the 2 shorter sides together. So it's like in between, okay? So like if we look at letter A, we said 5 centimeters. Is that bigger than 4? Yes. Is that bigger than 3? Yes, but it's not bigger than 4 plus 3, which is 7, right? So it's going to kind of fit right into that little space. Same with B. 5.2 is bigger than 4.8, bigger than 2, but not bigger than 6.8. So it kind of fits in there too. So you can kind of use that as like a quick little check. Like obviously, if you still did a little math wrong, you could get it wrong still, but that's kind of a good way to see it where you're at. All right, what about letter C? 3.4. 3 and 1/4. Okay. 3 and 1/4 inches. Yeah, 3.4 would actually be a little bigger than 3 and 1/4. Mm-hmm. So if you wanted to do a decimal, it'd be 3.25 for the 1/4. Okay, what about letter D?
2.5 inches.
Okay, 2.5 inches. All right, so we now understand, okay, that we can find the lengths of these triangles by just using a ruler. Okay, in geometry, this is actually called the ruler postulate, which is a postulate is just like something that can be proved. Okay, so obviously, us using a ruler helps us prove it. Do we agree? Okay, we are going to jump back to activity 3 in just a little bit. Now I would like for you to really focus more on your graph paper, and that's where we're going to be kind of working our notes off of today. On which one? There you go. Oh, it's not. Oh, sorry, my screen's frozen. I was writing them all up there, but there you go. Yeah, you bet. All right, so if you will flip to the graph paper, okay, you're going to label the first one. We'll just say letter A. You can just do this right under or right next to the triangle that you already drew on your graph paper. And, oh my gosh, it's driving me crazy. There we go. Okay, sorry guys. So, okay, so letter A. Okay, we're going to be working with finding the length of the hypotenuse using the Pythagorean theorem, which again is a squared plus b squared equals c squared. Okay, we're going to use our graph paper from kind of here on out. Okay, so here is my triangle. Okay, it's flipped over on its side because one note is finicky, so it won't let me flip around. But here we'll say this is side A, this is side B. Okay, side C has to be across from the right angle, so that's side C for us right there. Okay, so let's say that side A is 5 meters, and we'll say that B is 12 meters. Okay, how are we going to use the Pythagorean theorem to figure out what the hypotenuse is? Because we obviously are now working off of a scale. Okay, so we can't use a ruler because we don't even really have the space for 12 meters in this classroom. So, what method are we going to use? Starts with an S. What method are we going to use? We have information on the triangle. Substitution. We're going to use substitution. Okay? When you're given information and then you're given a formula, the method you're using to put stuff into that formula is called substitution. Okay? So we have a squared plus b squared. So instead of a, I'm going to put parentheses, squared, plus parentheses, squared, equals c squared. Okay, what's A? Good, it's 5. Yes. What is B? Okay. So now we have some simplifying to do. Yeah?
Yeah.
What is 5 squared?
Um, 5 squared. 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 5 squared.
25. Plus, what is 12 squared? 144 equals c squared. Okay, what's our next step? I feel like we're being like maybe just too afraid or indifferent to make a guess. Like, just look at what you see. It says 25 plus 144. If you say add them together and I say not quite, like, I'm not bringing shame upon your entire family for the rest of your life. Okay? Just guess it. Yeah, we're just going to add them together. What's up, Joey? Yeah, there you go. So 169, okay, if we add them together. Okay, so now we have 169 equals c squared. Now, is c squared the hypotenuse? No, what is the hypotenuse? It's whatever the square root of 169 is. Because we got to get rid of what? To actually find c, we got to get c by itself. What's with c over here on this right side before I drew the radical? The exponent, okay? What is the inverse operation, or what's the opposite of squaring something? We've talked about this. Square rooting, okay? So we have to take the square root of both sides. When we take the square root of c squared, the radical and the exponent will cancel each other out. Just give us c. Okay? 169 is a perfect square. What is it a perfect square with? Say that one more time. 13. 13 times 13 equals 169. So C equals 169. Now, we can do that quick check. We're saying it's 13 meters. Is 13 bigger than both of those sides individually? Yes. Is it bigger than if you added those two sides together? No. Okay, so we kind of fit right into that sweet spot. Okay? Then we'll have to do prime factorization. Fun stuff. Also calculators. Okay, so let's do some on our own. Okay, so we have a triangle with, we'll say A is 8 feet and B is 15 feet. Please find C. Okay, we'll call this one letter B. Okay, you should be working on letter B. Okay, work through B and C. I just said C. My apologies. There we go. B is feet. Okay, C will be in inches.
He is. Bro, you can't be talking. He is. Whoa, I'm a whoa. Can you move A?
No, move B.
No.
So proud.
Wait. Be quiet. You have to hear all the stuff. What is like for no reason? You literally came back and
Yeah. I'm just listening.
Gavin, you're wrong. Let me see what you got. Gavin, I showed you mine.
don't ever do it. Hey, I didn't find out how what is They're hard, Ada.
I was gone.
In it. No, I don't know what happened. It was like at the front of the school. Like when we're waiting to go inside, we're waiting for our parents. Weird.
Why did that work?
I couldn't go it. It was last year.
And you would just do the same thing on C.
It wasn't really weird. It was
All right.
just like a normal.
Let's look at letter B, just to make sure we're on the right track. So we've got a squared plus b squared equals c squared. A is what? 8. B is what? 15 equals c squared. Okay. Then PEMDAS says that I need to do exponents. So 8 squared is going to be 64. 15 squared is going to be 225 equals c squared. 64 plus 225 is going to be 289. Solid. Okay. 289, luckily for us, is also a perfect square. What is the square root of 289? 17.
This is actually so cool.
Good. So here is what we will be doing. Okay. I'm actually still waiting. I have tried to purchase something. We'll see if it works. So the great thing about Pythagorean theorem is it's super easy to see it in real life. So what we can do, okay, is well, it's I'm about to. I don't want to confuse you. I'll get to it. I got a little excited for a second. Okay. Have we worked on number 2 yet? Do we need a little more time? Or letter C? Letter C. Okay. Okay. I had a good question about letter C a second ago, so if you're still working on it, this might apply to you. If you want to flip it to decimals to work, okay, the problem, that's totally fine. But you need to know that if they are giving you the question as a fraction, the answer will most likely be in a fraction form also, okay? So just be able to convert it back to a fraction. And if you're not sure how to do that, I can show you. It's very easy. Give you a couple more seconds on letter C.
Oh, that is my whole life, really.
What's up?
Why do you always try to say us with like diamonds?
Well, it's because gotta be prepared for it.
I got it so easily.
So my preference actually is to like keep fractions separate and make sure you know the skill. But the state of Oklahoma will test you over this skill, but they'll give you fractions. So if we don't practice it, you won't get used to it.
Do I need to go to class next? Because mine's on the wrong way.
To do what?
Like when I put 1/4 in front of it, it's
Probably have to reset it. Okay. Okay, so let's look at letter C. If you're still working on it, that's okay. I'll just get it set up. So we've got a squared plus b squared equals c squared. What's a? Yeah. Could you have also said 3/10? Technically, yes. Okay. What you make A and what you make B doesn't matter. Okay. All that matters is that C is the correct side. Okay. So we could say 2/5. Okay. I'm gonna keep it as a fraction for me, because that makes my brain feel better. And then we've got 3/10 as our letter B. Okay. What is 2/5 squared? Yeah, 4/25. Okay, 4/25 plus what's 3 over 2? Yeah. Okay, 9/100 equals Equals what? So 4 over 25 plus 9 over 100 equals 1/2. Is that what we're saying?
It's 1/4.
Like a radical.
Yeah, and then it's 1/2.
Nice. Okay. So it comes out to be 1/4 equals c squared. Okay. Keep in mind that when you take the square root of a fraction, okay, I'm going to rewrite it. It's the same as taking the square root of the top and the square root of the bottom, which is a little easier for our brains to see. Okay. The radical and the exponent will cancel out, of course. Just give us c. What's the square root of 1? 1. What's the square root of 4? 2. Okay. Your brain starts to kind of feel like it's counterintuitive when you start working between the number 0 and the number 1. As you multiply stuff, numbers get smaller. As you divide stuff, numbers get bigger. So, okay, let's just we'll just keep moving along. I'm gonna just minimize this so that we can keep moving. Okay, so let's do I don't know. Let's do another triangle. This will be letter D. Nice. Okay. So, for letter D, okay, and actually, this is, oh, dang it. This is kind of a new section. Okay, so this is finding the missing leg. Okay, finding the missing leg. So, up till this point, you've been given A. You've been given letter A. You've been given letter B. And you've been finding C. On this one, you're going to be given C and then either A or B, and you have to find the other. Okay, so we'll call this A. We will call this 2.1 centimeters. And we will call this 2.9 centimeters. We have A squared plus B squared equals C squared. Y'all are really testing my ability to stay focused. And my ability to stay focused is not good to begin with. So, A squared plus B squared equals C squared. You are given two pieces of information. See if you can fill out. So, I mean, substitute incorrectly, okay, the numbers where they need to go. You have 2.1 and you have 2.9 in very specific spots. You already have the hip hop anonymous, yes. The hippopotamus, hip hop anonymous. You've never heard of the hip hop anonymous hippopotamus? Oh, okay. Get on YouTube, Jack. Jeez. Hippopotamies. Okay, I'm not going to finish working it, but this is how it needs to be set up. A squared plus 2.1 squared equals 2.9 squared. You're doing the same formula, but now you're just having to plug in different places. All right, see if you can finish out the problem. A should come out to a nice pretty number.
I'm saying for
For example, if I'm saying a nice pretty number, I'm actually saying a whole number.
a whole number. Are we still? Why is it a whole number?
What's it? You'll still take the x. So you're doing 2. Literally just. Say no. Okay, I'm going to give you about 45 more seconds on letter D right here. Be prepared for me to call on you.
Oh, what?
I said be prepared for me to call on you.
What if we don't know? What if I don't know the
And
answer?
go, wah, 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 wah.
That's really embarrassing. It makes me really anxious.
Everyone's getting such smart.
No, I know. Are you? It's like, oh,
Okay, I'm gonna finish letter D. I'm not gonna talk through it. I'm just gonna finish it. I would like for you to watch my steps and see if they match yours. Okay. Okay, where'd we go wrong? I think we went wrong right after this. I did not. 2.9 squared. I'll double check my 2.9. Yeah. Okay. So I would like. Did anybody get the same answer as me, but did it a different way? Walk me through it, Joey. What'd you do? Listen, please. This could be important to you.
So I put that first, like 2.9, and then minus 2.1 squared, like all that. And then 2.9 squared. I did the square, so 8.4, and then minus 4.41, and then equals 4.
So what Joey did is actually the exact same way that I worked it, but he set the problem up in a different way. So because we were looking for A, okay, Joey's thinking was, okay, I need to make it equal to A squared. Okay. In order to do that, you have to be able to move the B over correctly. Okay. Which Joey did because he had 2.9 squared minus whatever B squared was, right, Joey? And then you worked it from there. Okay. So I did that same thing. I just didn't do it at this step. I did it at the step right here. I moved the B over to the other side. Now, at this point right here, okay, that's where I ended up, and that's kind of where Joey started. So we kind of went like this, but we got to the same spot. Okay, and that's totally fine. Okay, now we did a little bit of some solving equation stuff. Okay, if you're working away from a variable, okay, you've got to undo whatever is happening to the variable. So at this step right here, okay, at that step right there, I would love for you to be looking at the screen. Okay, at that step right there, I have to get 4.41 to the other side because it's being added. I have to do the opposite of that, which is subtract from both sides. Okay, then that's how I got 4 on the right side right here, and just a squared left on the left side, and then you can finish it from there. Okay, so you've got to kind of go through your steps of algebra once you're working on these where you're finding the missing leg. Okay, so we are going to do more. We've got 2 more of these practice problems, and then I think I'm going to let you work on your homework for the rest of class while I check your folders. So let's do letter E. What's that? Yes, it's the very last page of your packet that you got right there. So letter E. We'll pretend that that's a we'll pretend that's a right triangle. It's not, but we'll pretend. Okay, you have letter E.
I don't know how to do this.
No, we will do something with that page, but that's not homework.
Is C on the practice page, but not the area, the answer? Because some of them say C, and then it's like some of them are B or A.
So you're talking about on these right here?
Yeah.
If it labels it C, that it's saying that one is the hypotenuse. Yeah. Okay, let's check letter E. Here we got A squared plus B. There's said plus B squared equals C squared. When we're plugging in, I'd plug in 16 squared plus, I don't know, B squared equals 34 squared. Let's see. What is 16 squared? 256 plus B squared equals, what's 34 squared? 1,156. Okay. Now what do we need to do? There you go. We got to get rid of 256. So we're subtract by 256 on both sides. 256 will cancel out on the left. I'll bring down B squared. It's going to equal, what is 1,156 minus 256? 900. How do we get rid of the exponent? So,
how do you? Oh, okay.
you good? Okay. Go for it. Yeah, square root it. Yep. We're going to square root both sides. That's going to make the radical and the exponent cancel out. Just give us B. And then 30.
Wait, I did do it right. But isn't it supposed to be bigger than both?
Were we looking for the hypotenuse?
Oh, no.
No.
No, we were looking for a leg. Yep.
Okay. I still did do it right.
Yep. Yep. Good job. All right, so here's your homework. Yep, your homework is the very last page of that packet that I passed out to you. There are 9 problems. Okay? I bet if you work on it right now, you've got a good 20 minutes. I bet you'd be able to finish. Okay? Please have your notes out on your desk. And I'm going to come around and check them.
This one?
Your whole where your math stuff is. Mm-hmm.